Hello friends, and welcome to my YouTube channel, Alan's Talent. Today I am gonna explain you all the structure of the Earth. So with leaving no time, let's start. So today the topics that we are covering are: Number 1. Structure of the interior of the Earth. And Number 2. Rocks and minerals. Before starting, I want to give you all some basics. Our Earth is unique as it has all the necessary elements for living beings to exist. The Earth came into existence some 5 billion years ago. The Earth is constantly under the influence of internal, as well as external forces. External forces are on the surface, whereas the internal forces are inside the Earth's surface. So friends, now let's move to our topics. Friends, now we will talk about our first topic, that is, structure of the interior of our Earth. But this topic will be explained by my friend, Joy, who is a geologist. So let's start.
Hello friends. As Alan said, I am a geologist. Joy. Friends, geologist is a person who studies the Earth. Now our first topic is structure of the interior of the Earth. As you all know, the Earth is a spherical body with a radius of 6,400 kilometers. A fun fact: Earth consists of several layers just like an onion. The layers are as follows. Number 1. Crust. Number 2. Mantle. And number 3. Core. Now crust. It is the thinnest layer of the Earth, also called the lithosphere. There are two types of crust. The continental crust, that is below the land mass, which is about 35 kilometers thick, and the oceanic crust, that is below the ocean, which is about 5 kilometers thick. Now mantle. The mantle just lies below the crust. It is positioned between the crust and the core. The mantle is 2,900 kilometers thick. The mantle consists of two layers, the upper mantle and the lower mantle. The average temperature of the upper mantle is 890 degrees Celsius. The lower mantle has an average temperature of 2,400 degrees Celsius. Magma is found in this layer. This red molten magma comes out from the interior of the Earth through volcanoes in the form of lava. Lava is rich in metals and minerals. The core is situated below the mantle and around the center of the Earth, with a radius of about 3,500 kilometers. It is also called knife, where Ni stands for nickel, and Fe for iron. It is called so because the core is rich in nickel and iron. There are two layers of the core, the outer core and the inner core. The temperature of the outer core is 2,200 degrees Celsius, whereas the temperature of the inner core is about 5,000 degrees Celsius. The temperature of the core is so high that the materials inside it is in molten form.
Thanks Joy, for a wonderful explanation. Now we will move to our second topic, that is, rocks and minerals. It will be explained by my another friend, who is a petrologist. Her name is Natasha.
Hello friends. As Alan said, I am Natasha, a petrologist who studies about rocks. And I will be explaining you all about our second topic, that is, rocks and minerals. So let's begin. The material that forms the crust of the Earth is called the rock. Rocks can be solid and hard. Minerals are natural substances found in the Earth's crust and contain one or more elements. They carry a definite chemical composition and physical properties. They may be metallic or non-metallic. A rock in which a particular mineral is found in a large percentage is called an ore. Mining is mostly done in those areas where ores are found. Now, what type of rocks are in nature? Rocks are classified on their type of formation as follows. Number 1. Igneous. Number 2. Sedimentary. And number 3. Metamorphic. Now, igneous rocks. The term igneous is derived from the Latin word ignis, which means fire. Igneous rocks are formed by the cooling of molten magma inside the Earth's crust, or on the surface of the Earth. These rocks are also called primary rocks. Igneous rocks are of two types: intrusive igneous rocks and extrusive igneous rocks. Let's move to intrusive igneous rocks. The rocks that cool down below the surface of the Earth are called intrusive igneous rocks. The rate of cooling is slow inside the Earth. They take thousands of years to form and develop large crystals. When the magma reaches the surface of the Earth and cools down, it solidifies and forms extrusive igneous rocks. Due to rapid cooling, such rocks are fine-grained. Rocks roll down, crack, and hit each other, and are broken down into small fragments. Running water, wind, moving ice, plants, and animals also break down the rocks into small particles. These smaller particles are called sediments. These sediments are carried away by wind and rivers, and are deposited in lowlands, lakes, and ocean beds. These sediments are deposited in layers. With the passage of time, these layers are hardened to form rocks. These rocks are called sedimentary rocks. Now let's talk about metamorphic rocks. Under very high temperature and pressure, igneous and sedimentary rocks change their form. Such changed rocks are called metamorphic rocks. These rocks are very hard. The process of metamorphism takes thousands of years. These rocks do not have empty spaces in them. After changes, these rocks remain in their original position. Now let's see what is rock cycle. Rock cycle is the process in which one type of rock is changed into another type in a cyclic manner under certain conditions. Through this continuous process, older rocks are transformed into new rocks by means of erosion, depositions, pressure, melting, and cooling. It is an endless process by which rocks are formed, destroyed, and formed again. Let me explain more precisely. When hot molten magma cools down, it forms igneous rocks. These rocks are broken down by different agents of weathering and erosion to form sedimentary rocks. Under extreme temperature and pressure, igneous and sedimentary rocks are changed into metamorphic rocks. The sedimentary and metamorphic rocks are buried again and melt to form magma. This magma again forms igneous rocks on cooling down.
Thanks, Natasha, for a wonderful explanation.